Hello students, let us continue with the chapter 7 Coordinate Geometry. As we have already discussed about the meaning of coordinate geometry and distance formula, today we are going to discuss about section formula. Now, if I will consider a line segment AB and I need to divide this line segment into two parts. So, I can take a point here, this can be a point D. So, it is not necessary that the point D will divide the line segment AB into two equal parts. So, they may be equal or they may not be equal. So, the ratio in which the point divides the given line segment can be found if we know the coordinates of that point. Suppose the line segment AB is divided in the ratio m is to n and I need to find out the coordinate of the point D. So, I can find it out. Also, it is possible to find the point of division if we know the ratio in which the line segment joining two points has given. If I know the point, I can find out the ratio, or if I know the ratio in which the line segment is divided, I can find out the point D. So, this is only possible with the help of section formula. So, section formula is used to determine the coordinate of a point that divides a line segment joining two points into two parts such that the ratio of their length is m is to n. Now, let A and B be the given two points x1, y1 and x2, y2. So, what we have to do, just plot these 2 points in a plane which is a coordinate plane. So, A x1, y1 and B x2, y2. Now, consider a point P which is x, y. The point P is dividing the line segment AB internally in the ratio m is to n. So, this is the ratio m is to n. So, the section formula for determining the coordinates of point P which is x, y is given by m x2 plus n x1 upon m plus n. So, you will get the value of x. For y, what you have to do? Consider the y coordinates m y2 plus n y1 divided by the ratio which is m plus n. So, this is the section formula. Now, we will discuss how you will derive this formula. So, again we have to consider 2 points, let P x1 y1 and Q x2 y2 be 2 points in the xy plane. So, here is point P, here is point Q and we have taken a point M which is x, y be the point which divides the line segment PQ internally in the ratio m is to n. Now, what we need to do? We will consider these 3 parallel lines parallel to y axis which is PA, MN and QR. So, PA, MN and QR are drawn perpendicular to x axis and PS and MB, PS and MB are drawn parallel to x axis. This is PS, this is MB. Now, as you can see, this angle MPS and QMB, these are corresponding angles. So, they are equal. Also, angle MSP is 90 degree and QBM is also 90 degree. So, both the angles are of 90 degree. So, by AA similarity, what you will get? Triangle PMS and triangle MQB. This triangle and this triangle. Both are similar. So, what will be the ratio of their sides? PM upon MQ will be equal to PS upon MB. Also, this is equal to MS upon QB. And I know that PM is M and MQ is N. So, all the ratio of these sides will be equal to M upon N. Mark this equation as 1. Now, I need to find the value of PS and MB, MS and QB. How you will find the value? Now, PS is what? What is PS? ON minus OA. Now, what is ON? Total is X. And what is OA? This is X1. So, you will get PS as X minus X1. Now, how you will find the value of MB? MB is what? MB. The total is X2 and this is, what is this? X. So, how you will get MB? As MB is parallel to NR, so you will get X2 minus X. So, now you will find the value of MS. What is MS? MN minus SN. You will get Y minus Y1. For QB, it is QB. It is QR total minus this. What will you get? Y2 minus Y. Now, you have all the values with you. You have to simply substitute the values. You will get M upon N is X minus X1 upon X2 minus X is equal to Y minus Y1 upon Y2 minus Y. Now, first you will consider this. What will you get? Solve it for X. You will get Mx2 plus Nx1 upon M plus N. Now, if you will solve for Y, you have to consider this equation. Y minus Y1 upon Y2 minus Y. Solve for Y, you will get My2 plus Ny1 upon M plus N. So, the coordinates of point M, which divides the line segment joining points Px1 y1, Qx2 y2, internally in the ratio M is to Nr, Mx2 plus Nx1 divided by M plus N and My2 plus Ny1 divided by M plus N. So, this is known as the section formula. Now, the coordinates of the point A, X, Y, which divides the line segment joining the points P, X1, Y1 and Q, X2, Y2 internally in the ratio M1 is to M2, means I have 2 points P, X1, Y1 and Q, X2, Y2, and there is a point which divides this line segment in the ratio M1 is to M2. So, this point which is A, X, Y can be find out by using the section formula as M1 X2 plus M2 X1 divided by the ratio which is M1 plus M2. And for Y, what will you do? M1 Y2 plus M2 Y1 divided by the sum of the ratios which is M1 plus M2. You have to simply replace the section formula, the value of M is to N, which is the ratio, by M1 and M2. You will get this formula. Now, if the point M divides the line segment joining points P x1, y1 and Q x2, y2 internally in the ratio k:1. Now, instead of M1, M2, now I have taken k:1. So, what will you do? First, we have defined the section formula for the ratio m:n. Then, we have replaced m by m1 and n by m2. Now, it becomes k:1. So, what will you do? Instead of m or m1, you will write k, and instead of n or m2, you will write 1. So, just replace m1 by k and m2 by 1. You will get k into x2 plus 1 into x1 divided by the sum of the ratios, which is k plus 1, and for y coordinate k into y2 plus replace m2 by 1, 1 into y1 divided by sum of the ratios, which is k plus 1. Now, let us understand this with the help of an example. Find the coordinates of a point which divides the line segment joining the point 4, 6 and -5, -4 internally in the ratio 3:2. Means what? I have a point 4, 6 and another point -5, -4, and this is divided, let some point by x, y in the ratio 3:2. So, here x1, y1 will be 4, 6 and x2, y2 will be -5, -4, and the ratio is given as 3:2. So, by using section formula, can you find this point? Yes, we can. How? The section formula says, suppose this is m1, m2, this is x1, y1, this is x2, y2. Now, according to section formula, we have mx2 plus nx1, or we can say m2 x1 plus m1 x2 divided by m1 plus m2, and for y we have m2 y1 plus m1 y2 divided by m1 plus m2. Now, simply substitute the values for this. What will you get? 3 into -5 plus 2 into 4 divided by 3 plus 2, and for y 3 into -4 plus 2 into 6 divided by 3 plus 2. After solving, you will get -15 plus 8 in the numerator, and in the denominator you will get 5, and for y in the numerator you will get -12 plus 12, and in the denominator 5. So, the value of x will be -7 by 5 and the value of y will be 0. So, the point P x, y will be -7 by 5, 0. Let us discuss few questions of exercise 7.2. Question number 2. Find the coordinates of the points of trisection of the line segment joining 4, -1 and -2, -3. For this, we need to consider 2 points P and Q. Now, point A is given as 4, -1 and point B is given as -2, -3. Now, let P and Q are the points of trisection of the line segment joining the given points. So, the line segment AB is divided into 3 equal parts, AP, PQ and QB. We need to find out the coordinates of the point P and Q. Suppose these 3 are equal. So, if I will not consider this point, I have to find the value of P, which is x1, y1 first. So, this is 1. Since this is divided into 2 equal parts, so I will take this as 2. So, the ratio will become 1:2. Now, I can apply section formula to find the coordinates of point P, which is x1, y1. How you will find out? See, 1 into minus 2 plus 2 into 4 divided by the sum of the ratios, which is 1 plus 2, 3. Now, if you solve, you will get minus 2 plus 8 in the numerator divided by 3. You will get the value of x1 as 2. For y1, what will you do? 1 into minus 3 plus 2 into minus 1 divided by the sum of the ratios, which is 1 plus 2, you will get 3 in the denominator. So, minus 3 minus 2 in the numerator. After solving, what will you get? Minus 5 by 3. So, the coordinates of point P, which is x1, y1 will be 2 minus 5 divided by 3. For the point Q, what will you do? Now, you will not consider this point. See, this part is 1 and this is divided by P into 2 equal parts. So, this will be 2. So, now the ratio will become 2:1. How you will find the coordinates of Q? X2, Y2. Now, for point Q, divides AB internally in the ratio 2:1. So, for x2, what will you get? 2 into minus 2 plus 1 into 4 divided by the sum of the ratios, which is 2 plus 1. What will you get after solving? Minus 4 plus 4 in the numerator divided by 3, you will get 0. For value of y2, how you will calculate it? 2 into minus 3 plus 1 into minus 1 divided by the sum of the ratios, which is 2 plus 1. After solving, what will you get? Minus 6 minus 1 in the numerator and 3 in the denominator. So, you will get minus 7 by 3. So, the coordinates of the point Q will be 0, minus 7 by 3. Now, we will discuss another question of this exercise, question number 4. Find the ratio in which the line segment joining the points minus 3, 10 and 6, minus 8 is divided by minus 1, 6. We need to find out the ratio and the point of division is given. So, we will consider the ratio as k:1. So, we have 2 points given as minus 3, 10 and B as 6, minus a, and the point which is x, y is given as minus 1, 6. And we need to find out the ratio which I have considered as k:1. So, apply the section formula for x. How you will find out? X k into 6 plus 1 into minus 3 divided by sum of the ratios, which is k plus 1. So, what will you get? 6k minus 3 divided by k plus 1. And you know what is x? X is given as minus 1. So, simply substitute x as minus 1, you will get this equation. You have to solve for k. How you will get? Just simply solve it. You will get the value of k as 2 by 7. As you have considered the ratio as k is to 1, this is 2 by 7 is to 1. What will you get? 2 is to 7. So, the ratio is 2 is to 7. Now, these are the questions for your homework. Question number 1, find the coordinates of the points which divide the line segment joining A minus 2, 2 and B 2, 8 into 4 equal parts. Question number 2, find the area of a rhombus if its vertices are 3, 0, 4, 5, minus 1, 4, minus 2, minus 1 taken in order. For this, I have given a hint. You simply find the area of rhombus as half into product of its diagonal. So, simply find the length of the diagonals, you will get the answer. Third, find the coordinates of a point A where AB is the diameter of a circle whose center is 2 minus 3 and B is given as 1, 4. Let us quickly recapitulate what we have discussed today. Let P and Q be the given 2 points x1, y1 and x2, y2 respectively, and M be the point dividing the line segment PQ internally in the ratio M is to N. Then the section formula for determining the coordinates of a point M is given by mx2 plus nx1 divided by m plus n and my2 plus ny1 divided by m plus n. And if the ratio is m1 is to m2, then the formula becomes m1x2 plus m2x1 divided by m1 plus m2 and m1y2 plus m2y1 divided by m1 plus m2. I hope you have understood the concept taught today, which is section formula, very well. Thank you.